we got a comment on our video to explain my coffee roasting theory, showing the graphs and all. So this video is for the person who commented. I hope you like the video, and in this video you can see different phases using graph. Hey guys, welcome to my channel, and this is the second video of the same series, roasting coffee with Carococo Coffee Roasters. In my previous video, I explained basics about coffee roasting, what coffee roasting means, how we do roasting in Cafe Sukoon. I showed you the machine. I explained you how heat is transferred through conduction, convection, and radiation. So we discussed about three phases, which is drying phase, then we talk about Maillard, browning phase, or you can say Maillard phase, and the third one we discuss about development phase, which is after the first crack. So let's continue with this coffee roasting with me, and today I'll take a deep dive into the technicalities of coffee roasting, and I'll try to I'll show you how coffee roasting software works, what is the bean temperature, what is the environment temperature, what is rate of rise, ROR, and we'll discuss about DTR, development time ratio, and let's continue. So coffee roasting is just turning your green beans brown, developing taste, flavors through the transfer of heat. So again, I'll be using this electric Mill City coffee roaster, and it has a heating element, it has a rotating drum. We can I can adjust drum speed, I can adjust the amount of heat which is transferred in this. I can adjust the amount of airflow using this control panel, and this is the cooling tray. And I'll show you some some of my roasting graphs as well to explain this. Hope you guys can see the roaster scope over here. Hope everyone can see this graph. This is basically a roasting curve, we say, or you can say roaster scope. So this is my roasting profile. So I have a blend which has 80% of Arabica washed natural and 20% of Arabica washed natural from Kararikant and 80% from Babra State. Both has very unique flavor. So I made this blend for myself because I like nutty, chocolatey, fruity espresso, and I have 25% of development time in this one. So let's continue. So these are the three phases which I have explained in my previous video. So this is the green color phase, is known as a green phase, where the coffee they are drying, so they turns yellow. All the water content inside the beans starts evaporating, and the color change happens. So the color change happens. Once the color change happens, after that the another stage comes, which is known as a Maillard reaction, Maillard phase. It is highlighted in light yellow. So Maillard, where all the chemical reactions happen, caramelization, chemical reaction happens, proteins, carbohydrates, fluids, they all break down through heat. And the third is the dark brown, which is known as a development phase. This phase comes after the first crack, and this is the phase where I choose whether I have to how much I have to develop my coffee. Also, it depends what roast I am doing. I'm doing a light roast or a medium roast. I'm roasting for espresso, I'm roasting for manual brewing. Totally depends on this phase. So for me, all phases are important, but development phase is very crucial for me. So I pay a lot of attention on this one. As you can see, the amount of time I have spent in the green phase is around 3 minutes 32 seconds, which is 37% of my entire roast. The amount of time I have spent in Maillard is 3 minutes 30 seconds, and then in development is 2 minutes 23 seconds. So this is my charge temperature. So I have, as I told you, the charge temperature is the temperature at which I am about to drop my coffee beans inside my drum. And we have environmental temperature, which is basically, in a layman term, I can see it's an energy inside the drum. So I have dropped my coffee to a charge temperature of around 210 degrees Celsius. It's a washed natural coffee. It requires a lot of heat to break down all the lipids. And the curve you see, so initially my beans are at room temperature. When they goes inside the drum, they start absorbing the heat, the environment which is inside the drum, the energy inside the drum, it start absorbing. So that's why you see a drop in the temperature, and this is known as a turning point. And the turning point is from where the bean starts actually, they have enough energy to start increasing the temperature. So let's assume my beans are at room temperature of around 45 degrees Celsius, and my roaster is heated at 210 or maybe 220. So when I drop the beans, I see a quick drop in the temperature because those beans are absorbing the energy of my roaster. That's why the probe is sensing that. So basically there are the probes which records the probes are basically sensor which records the temperature inside the drum. And then my turning point comes at 1 minute 26 seconds. The temperature is 122.3 degrees Celsius, and the bean starts heating back again. Though they are heating, but the sensor starts activating, and you can see a quick rise in the temperature. So over here you see the blue curve which is going is my rate of rise. It is basically the time or the rate at which my beans are absorbing the heat. So there are two ways you can configure in your artisan basis of 30 seconds or 60 seconds interval. So it means within 30 seconds how much my beans are absorbing the heat. This is very important, that you should have a declining rate of rise. There are a lot of theories why, and it's all about practical. So you can taste your coffee after roasting, and you can understand why declining rate of rise is so important. So this is the peak rate of rise over here, and after that my rate of rise gradually decreasing. My drying phase ends at 4 minutes at about temperature 155.4 degrees Celsius. This is my drying end. So this is basically the phase where my beans turn green, from green to yellow. And after that, I came to Maillard phase, where all the proteins and lipids, all aminos are breaking down to form good flavors in the coffee. I tend to decrease my temperature at around 165 degrees Celsius. So over here, the before the first crack, heat is being absorbed in the in the green beans. So once you hear the popping sound, so my target is how I achieve this declining rate of rise. After 165 degrees Celsius, I keep on decreasing my gas or my electric heat for 10 to 15 degrees Celsius, depending on the green coffee I'm using. The reason is because I want to slow down the roast. I don't want to achieve first crack too early. Also, once first crack is we are near the first crack, you will see exothermic reaction happening where you know where you cannot control your heat. So the coffee beans has so much amount of pressure and heat, it starts having an exothermic reaction. So I wanted, before it happens, I should slow down my gas. I can slow down my heat so that I can control my roast. My first crack comes at 7 minutes and the temperature of my first crack is 187.2 degrees Celsius. You can see a drop over here, slight drop. This is where where I have reduced the heat a little bit more, and after this you can see a bit rising. It's because it's an exothermic reaction, so you really have to control this slope. Otherwise, it will start increasing again, and you can get a harsh tasting coffee, a little bitter. After first crack, there is a development time, so I spend 2 minutes 23 seconds in development time for around 25% of my entire roast, and my rate of rise was here is 5 degree Celsius per minute, which is quite fine. So I have again a declining rate of rise, and my top temperature of this coffee was 200 degrees Celsius. So I dropped this coffee at 200 degrees Celsius. So this has enough development time for making the body. Another graph I can show you. This is the one. So this is a bit different coffee which I am roasting over here. This is also washed natural coffee, but you can see entire curve is different. My slope is quite decent in this one. I have spent 4 minutes in drying and 3 minutes 58 seconds in Maillard. So 36% my time was spent in Maillard. I had a very, I had a quite slow roast so that I can spend more time on Maillard where sugar starts developing, and I had a proper breakdown. So the more I spend time in Maillard, the sweeter my coffee is. And then I have spent 2 minutes 55 seconds in development time. So this was an espresso roast, and this tastes amazing. So this is the rate of rise, and the yellow one is the rate of rise for my my environmental temperature. You can see a slow drop, a peak drop, because at the time I was checking the beans, so that's why. So these sensors are quite heavy. At the end, I try to increase the airflow. The green line inside, it's my airflow. I keep it constant, but once after first crack happens, in the development phase, I play with the airflow to have a decreasing rate of rise. And also sometimes when I see that my my roasting is going out of my hand, I try to slow down my drum speed. It totally depends on machine to machine and what coffee you are roasting.